This research paper, titled LLM-assisted Graph RAG Information Extraction from IFC Data, by Seema Iranmanesh, Hadil Sadani, and Edler Avakaj from Birmingham City University, explores how large language models can simplify working with complex building information data. At its core, the paper addresses the challenges of handling IFC data, which stands for Industry Foundation Classes. This is a standard format used in the construction industry for sharing and managing building information across different software and teams. IFC data serves as the backbone for building information modeling, or BIM, which is essential in architecture, engineering, construction, and operations. BIM helps professionals manage and exchange detailed information about buildings throughout their lifecycle, from design to maintenance. The IFC standard, developed by Building Smart, allows for storing and sharing data on elements like walls, doors, and floors in a structured text file. However, these files are incredibly complex because they support multiple ways to represent the same information, making them hard to parse without specialized knowledge. The authors point out that working with IFC data typically requires deep technical expertise in the IFC schema, as well as experience with BIM software. For instance, users often need to manipulate tools to extract specific details, and even open-source parsing tools can lose important semantic meanings when combining or comparing data from different IFC files. This complexity can lead to incomplete or irrelevant results if the extraction methods aren't handled perfectly. To address these issues, the paper reviews previous research efforts. Many studies have tried to automate IFC data parsing by converting it into other formats, such as using mapping rules, graph-based technologies, structured query languages, or ontology-based approaches. For example, some methods rely on graph theory to represent relationships between building elements, while others use query languages to pull out attributes. However, these techniques often demand that users have in-depth knowledge of query formulation and mapping rules. If those rules are incomplete, the extracted information might not fully meet the user's needs. More recently, researchers have turned to natural language processing, or NLP, to make IFC data more accessible. NLP methods include syntactic tagging, dependency rules, and keyword classification to enable natural language queries and responses. These approaches have shown promise in simplifying information extraction from BIM data, allowing users to get answers without complex reasoning or heavy computations. For instance, query answer systems can directly pull data from BIM models using everyday language, which speeds up the process. Building on this, the authors of this paper advance NLP techniques by incorporating generative artificial intelligence, specifically large language models like GPT-4o, combined with a method called Graph RAG. Graph RAG is a specialized version of Retrieval-Augmented Generation, or RAG, which integrates graph structures into the retrieval and reasoning process. In simple terms, RAG helps language models fetch and use external knowledge to generate better responses, and Graph RAG takes that a step further by organizing data as graphs. Why is this useful for IFC data? Well, IFC data naturally lends itself to graph representations. In IFC standards, building components like walls, doors, and floors are connected through various relationships. For example, nodes in the graph could represent entities such as an IFC wall or an IFC door, along with their attributes like material or load-bearing capacity. Edges would then show the connections, such as spatial containment, meaning how one element is inside another, or physical connections between elements. The paper explains that Graph RAG enhances generative LLMs by allowing them to retrieve and process this graph-based knowledge efficiently. This means users can ask questions in natural language, like, "What are the properties of the walls in this building?" and get accurate, context-aware responses without needing a complicated setup. The authors demonstrate that, despite the challenges posed by IFC's complex hierarchy, Graph RAG makes it possible to extract building object properties and their relations more effectively. One key advantage is that Graph RAG avoids retrieving isolated pieces of information. Instead, it considers the interconnected nature of IFC data, providing a more holistic view. For instance, when querying about a door, the system can pull in related data like its connection to a wall or its placement within a floor structure. This approach not only improves accuracy but also reduces the need for users to understand the underlying technical details. The research highlights two main reasons why GraphRag is particularly effective for IFC data. First, the inherent graph-like structure of building components aligns perfectly with how graphs work, making retrieval more intuitive. Second, by leveraging LLMs, the system can generate responses in plain language, which is a significant step forward from traditional methods that require specific queries or scripts. In their work, the authors show that this method enables a question-and-answer system where both queries and responses are in everyday language. This is crucial for the construction industry, where professionals from various backgrounds need to access and share information quickly. By parsing IFC data through GraphRag, the system overcomes limitations of earlier tools, such as losing semantics or requiring extensive manual intervention. Overall, the paper underscores how combining LLMs with graph-based techniques like GraphRag can transform the way we handle complex data in fields like construction. It demonstrates that this integration allows for more efficient, user-friendly information extraction, paving the way for broader adoption of BIM technologies in real-world applications.